Section 5.6, the Clausius Inequality. Remember, U is a state function. Therefore, if we have two processes, one reversible, the other irreversible, that connects the same initial state to the same final state, then the internal energy change should be the same, whether the process is reversible, like in here, or irreversible, like in here. Again, du is dq plus dw. For a reversible process, dq reversible is simply t times ds. dw reversible is simply negative p dv. And over here, this is the expression for the internal energy change in an irreversible process. Again, this is dq and this is dw. Now let's move this dv and this dv together. We have TdS minus dq irreversible to be equal to p minus p external times dv. Now I'm going to prove this side, the right-hand side of the equation, is always positive. Let's analyze two different scenarios. Scenario 1, p is greater than p external. Then the system should expand. dv is positive. This is positive. The product is positive. Scenario 2, p is smaller than p external. Then the system should be compressed. Therefore, this is negative and dv is negative. In the end, the product is still positive. Therefore, we see TdS is always greater than dq reversible. TdS is dq reversible. So you can say dq reversible is always greater than dq irreversible. So this is actually the Clausius inequality. TdS is greater than dq reversible, or ds is greater than dq reversible over t. For an isolated system, we know dq is always 0. For an irreversible process, we say dq irreversible is 0. We plug in this 0 to here. Now you can see the entropy change is positive because ds is positive. ds is greater than 0 over t. And we integrate this ds, we get delta s. Delta s is positive. That means the entropy of an isolated system always increases if the process is an irreversible process. What if you have a reversible process? Well, then the entropy remains constant. For the isolated system, of course. Now let's look at a cyclic irreversible process. Again, ds is greater than dq reversible over t, so this cyclic integral of ds is greater than the cyclic integral of dq irreversible over t. And because entropy is a state function, we have this part to be 0, and now we have another inequality. The cyclic integral of dq reversible over t is less than 0. And also, just by looking at this, you will realize that entropy is a state function. Therefore, the cyclic integral of this is 0. And this is a path function. Therefore, the cyclic integral of this is non-zero.